Welcome back for part 3 of chapter 1, section 3, tables of proportional relationships. And as I promised, we got cool volcanoes going on today. After a volcanic eruption, lava flows down the slopes of a volcano. The distance the lava flows is proportional to the time. Move through the slides to watch the lava flow for the given volcano. What is the constant of proportionality of the flow of lava? Think about it. Why is a table a good way to organize information? Well, a table allows you to visually see what the numbers look like. Not as good as a graph does, but you still organize it neatly, and you can break it down into per minutes and see if it makes it real easy to check for a constant of proportionality. So here, for each time, find the ratio, number of meters, and number of seconds. Then rewrite the denominator of 1, select a card to check your answers. So, the very first card set us up with 9 to 5. It traveled 9 meters in 5 seconds, and that one simplifies to a 1.8 to 1 ratio. The next slide did 27 meters. That's strange. I think they have their order mixed up. 18 meters to 10 seconds. And when we simplify that, you get the same 1.8 to 1 ratio. The third slide, you simplify, get the same answer. The fourth slide, you simplify and you get the same answer. So it doesn't matter how much time you look at, 5, 10, 15, or 20 seconds, they all simplify down to be 1.8 meters in 1 second time. Because the constant ratios are 1.8 to 1, the constant of proportionality is going to be 1.8. And the unit rate is going to be 1.8 meters per second. And what does per second mean? Per 1 second. Check your answer. Our answer is good. Let's keep moving. What does the constant of proportionality 1.8 mean in the context of the problem? Pause the recording. Write a sentence to justify that answer. Your sentence should have said something along the lines of the 1.8 represents how many meters the lava flows for each minute of time. Moving forward. The table shows the distance traveled by 3 cyclists during a race. And you can see they've got their distance compared to their time for each of the cyclists, Mara, Javier, and Kyle. And yes, it's not Javier, it's Javier. The J sound has an actual H sound to it. Rank the cyclists and their corresponding constant of proportionality, also known as their unit rate, from slowest to fastest. In other words, we want to be able to find out how fast each cyclist goes in a single hour of time. And 2 of those are actually given to us. We can see Mara was 11 miles in 1 hour. Javier was 12 miles in 1 hour. We really only have to take and figure out how fast Kyle went in 1 hour. And to do that, we would just take and divide 20 over 2 by 2, which means he went 10 miles in 1 hour. So let's drag the names and rates of to the appropriate bins. You pause the recording, take and do that for just a second, and then we will take and come back together and check it. Alright, let's look. We had 11 to 1, 12 to 1, and we simplified the 20 over 2 to be 10 to 1. That means Kyle had the slowest rate, which we're going to put here, and he was going 10 miles per hour because it's 10 miles per 1 hour. The next slowest is going to be Mara at her 11 miles in 1 hour. So we're going to put Mara here and put 11 miles per 1 hour. And then the fastest is going to be Javier at 12 miles per hour. We're going to put Javier in the fastest spot, put 12 miles per hour, check our answer. Everything checks. Good job. Now comes a part of the problem that we all live for, the apply. You need to pause the recording and work on this. Read the problem. In fact, it's going to tell you to read it 3 times To think about these things when you read it the 3 times, you're going to need to write down in words what strategies you can use to approach this problem, and then you need to find out what the solution is and put it in. Finally, how can you show your solution is reasonable? Write an argument to defend your solution. Pause the video and work on this. When I read the problem, I realized that they wanted to have a total cost, where they want to find out how much the sales tax is going to be, and then they want to find out what the total cost is going to be for an $84 purchase. That meant the easiest way to solve it is going to be to find out first what the total tax is going to be for $1. So I took and divided found my constant of proportionality, comparing it to $1 a purchase, and that's going to give me my tax rate. That means I'm going to have to flip the problem over. After I do that, I can multiply by 84 to find the total tax, and then I will finally add that tax rate to the $84 to find the total amount. Now, if you've not found the answer yet, pause the recording, because that is going to show you how to do that. I'm going to click done for my first part. Yes, I'm sure. Pause your recording, find out what your sales tax is and how much the total cost is going to be. Now, the first thing I need to do to solve this problem is find out whether or not the sales tax is going to be proportional. And I lost my pen. Here it is. And I could take and set this up by doing a unit rate for each one of these, and we're going to need to find out, we actually flip the problems eventually, but I could take and divide each of these out to find out if it's the same, but instead it's laid out on a table. So watch this. I'm going to take and say, well, let me get my marker going here. 12 times what is 24? It's going to be 2. And if I multiply the bottom by 2, I get 120. Well, good. How about 12 times 3? That's 36. And 60 cents times 3 is $1.80. And the same thing times 4 is 48. And so the bottom times 4, that's going to equal to $2.40. So the first answer is yes, it is going to be proportional. I put the wrong spot there. Where's our answer key? There it is. It is going to be proportional. Now we've got to calculate up the total cost, and that's where the real work's going to come in. The first thing I'm going to do is flip my numbers. I'm going to put the 60 cents on the top and the 12 on the bottom, because I want to find out how much tax there is for every $1 of purchase. When I divide by 12 over 12 to find the unit cost, or the unit ratio, I'm going to find out that it is going to be a nickel tax for every $1 of purchase. That's my tax rate right there. Now I'm going to take that number and I'm going to multiply it by 84, because we have $84 that we're spending times the nickel, and when we multiply that out, 5 times 4 is going to be 20, 5 times 8 is 40, plus the 2 from the 20 is going to be 42, bounce, 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 bounce. So now we know that the tax is going to be $4.20. And we're going to circle that. It's not the answer, but it is an important sub-answer. The final thing we have to do is find out the total cost. $84 spent plus $4.26 tax. Add that up, you get $88.20 for your total cost, which we're going to circle as well. Come back to our problem, type it in, $88.20. Check our answers. Everything checks. We have successfully answered that question. Now, I have explained how I solved my answer. I hope that you have taken and made a good argument of how you solved your answer right here. Now it asks us, if the relationship is not proportional, could you solve this problem? Not really, not with the skills we have at this time. Down the road, we may be able to figure out how to pull out that common, you get pay this first and then a tax rate. We're not there yet. So for what we have right now, nope, we do not have the skills to solve that problem if it's not proportional. For our final problem, Laura's writing a research paper. The table shows her progress. If the number of pages is proportional to time, how many pages will she complete in 7 hours? So you pause the recording, work this one out, and then we'll see what the answer is going to be. Alright, it's my turn. Now something important to notice about this problem is the wording they have here. It says, if the number of pages is proportional to time. That's saying, the number of pages are proportional with time. How many pages will she complete in 7 hours? Now we could take and find out the answer by first finding out how many pages she would do in 1 hour. We would take the 9 pages divided by 2, and that's going to give me a 4.5 to 1 ratio. Now, we don't really need to at this point divide the other one, but we can. 13.5 divided by 3, and when you divide that out, you still get the same 4.5 to 1 ratio. Now, the question wanted to know how many pages will she do in 7 hours. So to find that out, I'm going to take that 4.5 to 1 ratio, and I'm going to multiply it by 7 over 7. When I do that, 7 times 7, well, that's easy. That's the bottom number. The top numbers can be a little more challenging, so let's do some grunt work here. I'm going to say 7 times 5 is 35. 7 times 7 is 28. Plus 3 from the 35 is going to be 31. Bounce your decimal once. Bounce your decimal once. She should do 31.5 pages in that 7 hours time. Let's check our answer, see if I did it right. I'm going to take and type in the 31.5. I'm going to hit check, and the answer is correct. Now it is your turn to work the problems out for your homework. Make sure when you're doing this, you are showing me good quality supporting work. If you don't give me good quality supporting work, just like I've given you in these examples, you will have done it just for, that's right, just for fun. Don't want just for fun, we want just for that 10 points on the homework. Get started, show me your work. I look forward to seeing it turned in well.